Throughout history, since ancient times, humans have gazed at the stars and pondered the vastness of the universe. Now, however, we can say that the enigma of what lies hidden in the corners of the universe has finally been revealed. The James Webb Space Telescope has unveiled a discovery that is making a profound impact on the field of astrophysics and leaving scientists amazed. This finding is so revolutionary that it could completely change our current understanding of the cosmos. So, what exactly has this advanced telescope at the far reaches of the universe revealed? Get ready for an out-of-the-world experience as we'll delve into this groundbreaking discovery and its implications for the future of science. If you're interested in keeping up to date with news from the universe and beyond, subscribe to our channel. Be sure to like this video and turn on the notification bell. Imagine having a time machine that would allow you to witness the origin of the universe. Well, the James Webb Space Telescope gives us the opportunity to travel billions of years into the past and observe the far reaches of the universe in more detail than ever before. With its state-of-the-art infrared detection technology, the James Webb works like a superhuman eye capable of perceiving objects and phenomena invisible to us. What's the result? Astronomers have captured stunning images and gained invaluable information about the workings of the universe as a whole. These stunning images show galaxies and clusters, including the distant and elusive MAC SO647GD, perplexing the scientific community. The image reveals an astonishing spectacle, a stunning array of galaxies glittering like jewels in the vast emptiness of space. However, what really excites scientists about this image is not only its beauty, but the enormous amount of information it provides. MAC SO647GD, a distant galaxy discovered a decade ago by the Hubble Space Telescope, has been studied in greater detail thanks to the James Webb Space Telescope triple lensing effect, which seeks new insights into its structure, composition, and behavior. Scientists are especially fascinated by the question of whether MAC SO647GD is a single galaxy or two groups of stars within a galaxy, and hope the James Webb can provide them with an answer. But the James Webb discoveries do not end here. There is much more to discover and explore in the far corners of the universe. This cutting-edge telescope has opened the door to a new world of possibilities and is redefining our understanding of the vastness and complexity of the cosmos. The telescope has gone further, unveiling galaxies beyond our ability to imagine. And these are not just any galaxies, but some of the oldest galaxies in existence, such as Z12, which was captured just 350 million years after the Big Bang. Take a moment to take that in. This galaxy is more than 13 billion years old, and its discovery has revolutionized our previous understanding of the origins of the universe. Previously, the Hubble Space Telescope had observed the galaxy GNZ11, which existed just 400 million years after the Big Bang in 2016. However, thanks to the incredible capabilities of the James Webb, we have been able to see even further into the past, revealing galaxies that existed only 250 million years after the Big Bang. One striking example is the galaxy CEERS 93316, with an impressive redshift of 16.7. This is testimony to the unprecedented technological advances of the legendary James Webb Telescope. This galaxy is such an enormous distance that we are observing it in its early stage, and its discovery is part of the Cosmic Evolution Early Release Science Survey, which uses the James Webb to capture images of distant galaxies. Although spectroscopy is required to confirm its redshift, preliminary NIR-CHEM data have already ruled out the possibility that it is a low-mass star or an unobstructed active galactic nucleus. The discovery of CEERS 93316 adds to the growing body of evidence suggesting that galaxies formed even earlier than previously thought. The exciting thing about this finding is that it transports us to a time before the stars we know today existed. It is like finding a hidden treasure that takes us back to what is commonly known as the Dark Ages, a period when it is believed that the first galaxies in the universe began to take place. It's like having a time capsule that allows us to go back billions of years and get a unique glimpse of what our universe was like in its earliest days. The discovery of CEERS 93316 is just the beginning of what is possible. NASA has hinted that James Webb could detect galaxies at redshift greater than 20, just 200 million years after the Big Bang. This means that the discovery of CEERS 93316 is even more significant, as it offers hope that these elusive galaxies may actually exist. It opens up a whole new world of possibilities about what we might discover in the vast expanse of the universe. In the farthest reaches of the universe lies another fascinating galaxy that has scientists abuzz with excitement, Abell 2744y1. This galaxy lies at such a colossal distance that its light takes a staggering 13 billion years to reach Earth, making it practically as old as the universe itself. Despite this enormous distance, the Spitzer, Chandra, and Hubble telescope have managed to capture an image of this extraordinary galaxy by working together to collect data from different wavelengths of light. They even used the phenomenon of gravitational lensing, predicted by Albert Einstein, to obtain an image of Abell 2744y1. What is truly amazing about this galaxy is not only its age and remoteness, but also its incredible rates of star formation. Despite being only 50 times smaller than our own Milky Way, Abell 2744y1 generates stars at a rate 10 times faster than our own galaxy. This accelerated rate of star production is typical of galaxies that existed in the early days of the early universe. This impressive rate of star formation has puzzled scientists and piqued our curiosity to discover what else this galaxy has in store for us. Although exploring this galaxy in depth is no simple task, the information gathered so far will keep scientists busy for many years to come. Have you ever pondered the vastness of the universe? It is so vast that our minds cannot fully comprehend it. Yet, despite its staggering magnitude, scientists have attempted to measure it, and what they have discovered is truly astonishing. The observable universe has a radius of approximately 46.1 billion light years, but there is much more out there that is beyond our ability to observe. Based on observations and our knowledge of physics, scientists have determined that the universe extends on a globally flat scale with a remarkable accuracy of 0.25%. However, there is a possibility that the universe is curved and forms a loop upon itself. In such a case, the observable part of the universe could be at least 23 trillion light-years across and contain more than 15 million times the volume of what we can currently see. These perspectives invite us to reflect on the immensity and infinite possibilities that the universe holds, prompting scientists to explore and discover more of its hidden secrets. Some scientists even hold the possibility that the observable universe is considerably larger than what we know so far. According to this perspective, it is conceivable that the event known as the Hot Big Bang simply marks the beginning of what we can observe, but not necessarily the origin of space and time itself. However, this notion raises even deeper questions about what we do not know about the universe. According to the theory of cosmic inflation, the universe experienced a period of rapid expansion before the Big Bang, in which new space was generated at an extraordinary rate. This idea raises a number of unanswered questions about the scale and very nature of our universe. For example, how large was the region of the universe subject to inflation? And is the hypothesis of eternal inflation, where the universe expands indefinitely into the future in certain regions, plausible? Also, how long did the inflation stage prior to the Hot Big Bang last? It is likely that the universe where inflation occurred was only slightly wider than what we can observe, or that evidence of its limits will emerge in the future. Despite all these uncertainties, it opens up the fascinating possibility that there are countless additional universes out there, similar to our own in terms of physical laws and structures. This conjecture tantalizingly suggests the existence of complex life forms on some of these worlds. It is amazing to consider that we are merely a tiny particle in the grand scheme of the universe, with vast territory to discover. One example of this galaxy is GNZ11, which has been observed as the most distant galaxy ever detected by humans. It is at an impressive 32 billion light-years away from our planet. This means that the light we are seeing today from GNZ11 began its journey to us when the universe was just 3% of its present today. The magnitude of this distance to GNZ11 is so colossal that it is difficult to comprehend. Moreover, if we take into account the expansions of space, the distance from Earth to GNZ11 extends to about 46 billion light-years, almost half the total age of the universe. What makes GNZ11 even more intriguing is that it marks the limit of our observational capabilities. It lies on the surface of the last scattering, the point where the first photons emerged after the recombination and decoupling of matter and radiation. In a way, GNZ11 represents the edge of the observable universe, beyond which can see and explore nothing. As we contemplate the vastness of space, it is natural to feel small and insignificant. The universe is so vast and infinite that it can overwhelm us. However, as we delve deeper into the cosmos, we gain a better understanding of our place in it. By exploring the origins and evolution of the universe, we gain insight into the processes that have shaped it over billions of years. What is exactly the observable universe? The observable universe refers to the portion of the universe that we can observe and study using telescope and other instruments. However, this capability is limited because light, the main source of information about the universe, can only travel at a finite speed. As a result, we can only observe objects and events that are at a certain distance from us. We cannot directly see objects or events that occurred long ago in the past. The diameter of the observable universe is estimated to be approximately 93 billion light-years, which is much larger than the estimated age of the universe, which is estimated to be 13.8 billion years. This discrepancy is because the expansion of the universe has caused objects that were once close together to move away from each other, and light from those objects has required more time to reach us. Overall, the observable universe is a vast and fascinating space, but there's still much we don't know about it. However, through the use of telescopes such as NASA's James Webb Space Telescope and other scientific instruments, we continue to learn more about the structure, composition, and history of the universe, as well as its various phenomena. Join us as we discover the massive structure that the James Webb Space Telescope has just made contact with in the far reaches of the observable universe. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Now, what lies beyond the observable universe? To reach the far reaches of the observable universe, we would need to develop transportation methods that would allow us to transcend space-time, such as using distortion engines or wormholes. These concepts have long been the subject of debate among scientists, some of whom believe that they are simply impossible or they contradict the idea of faster-than-light speed travel. The feasibility of both possibilities, faster-than-light travel, and the use of advanced technology beyond the reach of current human intelligence is a subject of intense debate. Even if it were theoretically possible, it would require technological advances and machinery that are currently beyond our capabilities. The theory of cosmic inflation posits that the total size of the universe is at least 10 to the power of 23 times larger than the observable universe. This number is so vast that it is incomprehensible to the human mind, since we cannot see or measure the unobservable part of the universe. Therefore, we have no way of knowing with certainty what lies beyond its limits. However, that does not mean we cannot develop theories based on the information we have gathered from distant galaxies, and this is where NASA plays an important role. NASA, in collaboration with other space agencies and research institutions around the world, has made numerous significant contributions to our understanding of the universe. Even before the James Webb Space Telescope became operational this year, NASA had already released images of the ultra-deep field obtained with the Hubble Space Telescope. However, when the James Webb Telescope made its debut, it was taken out to observe the most distant galaxy ever recorded. These images revealed the presence of numerous galaxies shining in the distant cosmos,
apparently as they were millions of years after the Big Bang occurred, approximately 13.8 billion years ago. The expansion of the cosmos causes the stretching of light to redder wavelengths, which allows the James Webb Space Telescope to detect infrared light. This has allowed us to observe galaxies forming in the early stages of the universe's history. The James Webb Space Telescope has made observations of several fields of distant galaxies, allowing scientists to study the rate at which stars formed in the early universe. These data revealed the existence of a significant population of galaxies that were forming stars in the early stages of the universe. These discoveries are truly fascinating and thought-provoking. For a long time, humans have contemplated the possibility that we are not alone in this vast universe. However, these new determinations within the observable universe leads us to believe that there must be millions of galaxies in the unobservable part of the universe. This idea is truly shocking and awakens a sense of awe and wonder about the vastness of the cosmos. Are there extraterrestrial beings somewhere in the universe? The likelihood of life beyond Earth has never been more compelling, leading us to consider the possibility of the existence of extraterrestrials. There are numerous planets outside our solar system known as exoplanets, which have been discovered using techniques such as the transit method and the radial method. Some of these exoplanets may have similar characteristics to Earth and may harbor life. This theory has been supported by another discovery made thanks to the James Webb Telescope related to the exoplanet WASP 96b. This planet is outside our solar system, and its light spectrum revealed something surprising: the presence of water molecules. In addition, the spectrum also shows hints of haze and clouds, which were not previously thought to exist on a habitable planet. Based on the habitable environments found elsewhere in the universe, and considering the advances in the search for exoplanets, it is difficult to rule out the possibility that alien beings exist beyond our planet. Although we do not yet have conclusive proof, discoveries and evidence suggest that the existence of extraterrestrial life is a fascinating possibility. What about the multiverse in relation to the vastness of the observable universe? Let me tell you, the possibilities are endless. The concept of the multiverse, also known as the many worlds interpretation, is a theoretical idea in physics and philosophy that suggests the existence of multiple parallel universes or dimensions beyond our own. The multiverse is mainly discussed in the context of quantum physics, which deals with the behavior of tiny particles such as atoms and subatomic particles. According to some interpretations of quantum physics, the act of observation can cause a quantum system to collapse into a single state. However, in the many worlds interpretation, the act of observation simply causes the system to split into multiple states, each representing a different outcome. It is important to note that the idea of the multiverse remains highly speculative and is not yet supported by conclusive evidence. It is therefore difficult to state with certainty whether it is a valid concept or not. Some scientists and philosophers find the idea of the multiverse intriguing and potentially useful in explaining certain phenomena, while others are skeptical about its validity. Given that we do not know what lies outside our universe, the possibility of the existence of a multiverse remains as valid as the famous Schrodinger's cat thought experiment, or the nature of darkness. It is a concept that arouses fascination and reflection, but requires more research and evidence to be confirmed. Does the phenomenon known as dark flow exist? The question is complex and raises an intriguing issue. Dark flow came about in 2008 as a possible explanation for the observation that some galaxies clusters appear to look faster than expected based on the distribution of matter in the universe. The concept of dark flow suggests that these galaxy clusters may be influenced by some form of dark matter or dark energy that pulls them in a specific direction. However, the existence of dark flow remains controversial and has not yet been accepted by the scientific community at large. Some studies have suggested the dark float may be real and could be caused by the presence of a massive structure in the universe that exerts an attraction on galaxy clusters. However, other studies have failed to confirm the existence of dark float and have proposed that the observed motion of galaxy clusters could be the result of other factors, such as systematic errors in the detected ones. While other studies suggest its possible existence, we cannot say with certainty its presence outside the observable universe. More research and evidence is needed to better understand this intriguing phenomenon. Although the universe is vast and can extend infinitely, there are boundaries and inaccessible places that we cannot reach, even if we travel at the speed of light. This is why the detection of a traveling signal from the edges of the universe by the James Webb Telescope is of great importance. Recently, after the first images from the telescope were released, researchers have presented stunning images of spiral galaxies. Today, we will talk about the incredible discovery by the James Webb Telescope at the edge of the universe. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it so it reaches more people, and activate the notification bell. New images captured by the James Webb Telescope are helping to understand some of the most fascinating questions we have about our universe. These images include giant planets, stars in the late stages of life, violently colliding galaxies, and ultra-diffuse galaxies. One of the most remarkable images captured by the telescope is of a massive swirling spiral galaxy that is enveloped in purple-colored cosmic dust. These stunning images are opening up new discussions and debates about what is going on in the vast and infinite universe. According to the U.S. space agency, ANGC 628 is the name of a distant galaxy recently captured by the James Webb Space Telescope. Gabriel, an astronomer at the Cosmic Dawn Center at the Niels Bohr Institute at the University of Copenhagen, has shared the image on Twitter and commented that this galaxy, seen as a dusty skeleton, resembles our own Milky Way. Individual star nodes and supernovae can be seen shooting out, which can be studied in detail. NASA has confirmed that the spiral arms of ANGC 628 have been photographed previously, but Hubble Space Telescope images in visible light do not show the same purple spiral structure seen in the mid-infrared image captured by the James Webb Space Telescope. Dr. Brammer explained that the same galaxies seen through the Hubble Space Telescope or ground-based telescope do not show the same impressive view that can be seen through the James Webb Telescope. Through the latter, one can see blue stars, red stars, spiral arms, and dust lanes. He explained that the dust streaks, which are reddish-brown filaments in the spiral arms, tend to obstruct the view of stars in the visible images captured by the Webb. However, in this case, we can see the light-emitting dust directly. Instead of seeing stars, you can see an image of the gas and dust in the galaxy ANG 628, photographed by Webb earlier this year and stored in the MATS Public Space Image Library, which anyone can access. The James Webb Space Telescope has not been idle since NASA released the first 5 color images. It has been constantly capturing new images and uploading them to the MAX archive for astronomers to access. According to Dr. Brown, the telescope has captured something truly spectacular, a galactic whirlwind at the edge of the universe that is incredibly beautiful, but also haunting. In addition to this stunning image, the telescope has provided compelling evidence that the universe is full of amazing phenomena and objects. For example, it has discovered that a star in the galactic swirl is surrounded by concentric rings of light that emit radiation outward. Although Webb's diffraction peaks are not real, the rings are, and there is a disturbing explanation for how they formed. The star that has been observed with the James Webb MIRI telescope is actually a binary pair of rare stars in the constellation Sagittarius. These two stars experience periodic eruptions of dust that accumulate in layers and glow in the infrared, which has allowed the MIRI to observe them in detail. They are a binary system called coalition wind, consisting of a hot, massive O-type star and a massive WO star. NASA scientists are concerned about the discovery of this unusual object and the obvious connection between these Wolf-Rayet stars, which are massive stars in the advanced stages of their lives and losing mass at an accelerating rate due to the nuclear fusion of heavier elements such as helium or carbon. They are very hot, very bright, and old due to their massiveness, which means that their lifetime is short. The two stars in the WAR 140 system have powerful stellar winds blowing at a speed of about 3,000 kilometers per second, causing them to lose mass rapidly. The elliptical shape of the object's orbit adds to the fear, as it indicates that the star describes ovals rather than perfect circles. When the stars get close enough at the periastral point, which is 1/3 larger than the distance between the Earth and the Sun, they may collide. This collision causes the acceleration of particles and the creation of energy radiation such as X-rays. The interaction of stellar winds also causes the formation of dust puffs, which are partial dust layers that expand and cool, observed at infrared wavelengths by the James Webb instrument. This dust is a type of carbon that absorbs ultraviolet radiation from the two stars and is heated by the stellar wind before being expelled. In other words, the Webb images show a concentration of denser material in the form of bubbles at the edge of a dusty layer, which is more visible due to the perspective and the 7.94-year orbit period of the binary system. The combination of wind and dust production produces airborne particles that allows the age and outermost visible layer to be determined. Rings can be seen in the nebula surrounding the binary, similar to 3 rings, and about 20 rings are visible, which means that about 160 years of dust layers can be seen. The most recent WAR 140 Petriastro was discovered in 2016 by a group at the Japan Aerospace Exploration Agency's Institute of Space and Astronautical Science, led by astrophysicist Ryan Lowe, so expect to learn more about it in the future. The concept of the edge of the observable universe is an intriguing notion within cosmology, the branch of science that studies the origin, evolution, and structure of the universe as a whole. Although the exact details may vary according to the latest cosmological theories and models, there are certain fundamental ideas that apply to this concept. The observable universe refers to the region of the cosmos from which light has had sufficient time to reach us since the beginning of the universe. Since the speed of light is finite, the portion of the universe that we can observe is limited by the distance that light has been able to travel since the Big Bang, the event that is believed to have marked the beginning of the universe as we know it. This means that there are regions beyond our observable sphere that we have not been able to detect because the light they emitted has not yet had time to reach us. There are several fascinating insights related to the observable reaches of the universe. Particle horizon. Due to the expansion of the universe, there is a limit beyond which particles and galaxies are moving away from us faster than the speed of light. This creates a horizon beyond which we cannot receive any information, since light or any other signal cannot reach us from some time. Age of the universe. The age of the observable universe is related to the maximum distance we can see. The farther we look in space, the further back in time we go, since light from those distant regions has had to travel for miles of millions of years to reach us. Topology and shape of the universe. The overall size and shape of the universe is subject to debate. Some theories suggest that the universe may be finite, but have no clear edges or boundaries. This implies that, in theory, we can look in one direction and see the same point in space from an opposite direction. Multiverses and other theories. Some cosmological theories, such as cosmic inflation and related ideas of multiverses, suggest the possibility that the observable universe is just one part of a larger set of universes or dimensions, which adds even more complexity to the concept of boundaries. And well, we will be on the lookout for new information about it to keep you informed. Thank you very much for watching the video. Remember to like and subscribe, and see you in the next one.